In this video, you will learn the basic rules of trigonometry. Let's start off by defining what trigonometry is. Trigonometry is the study of side lengths and angles, and in this video, we will mainly be looking at triangles. Now let's start off by defining the side lengths of these triangles as well as its angles. So this right here is triangle ABC, and this just means that it has vertices A, B, and C. Now if you want to name this side length right here, this blue one, how would we do that? Well, we could call this side length AB or side length C. They both mean the same thing. We call it AB because it's in the middle of vertex A and B. And we can also call it C because it's opposite to vertex C. Either way, you can call the side length AB or side length C. Now what about this angle over here? How do we name this angle? Well, to name this angle, we would just call this angle ACB. The letter in the middle, the C, tells us where the angle is, and the A and the B are the two vertices that make this angle. Now, what if we have a triangle like this, and we had an angle right here? This side right here, side length AB, would be opposite to this angle, because it doesn't touch the angle, rather it's opposite to it. This side length right here, AC, is adjacent to the angle because it borders the angle. And this right here is the hypotenuse because it's the largest side and it's opposite to the 90-degree angle. So before we begin, make sure you understand opposite of an angle, adjacent of an angle, and the hypotenuse of a triangle. Now in this video, we will be covering sine, cosine, and tangent. These are the three ratios that are mainly used in trigonometry. Now let's start off with this example right here. So consider this triangle, triangle ABC, and this angle right here, angle ACB, which is 53 degrees. Now what if I asked you to find the sine of 53? How would you do that? Well, you would use this right here, SOHCAHTOA, and this is just an acronym. So the S in SO stands for sine, and since we're doing sine, we'll just focus on the SO. So the S in SO means sine, the O means opposite, and the H means hypotenuse. So what this is saying is that sine equals opposite divided by the hypotenuse. So sine 53 is going to equal the opposite, so the opposite side length is AB, which is 4, divided by the hypotenuse. So the hypotenuse is 5. So sine 53 equals 4 divided by 5. And this only works for right triangles. So make sure that when you're doing SOHCAHTOA, you're doing it for right triangles only. Now what if I told you to find the cosine of this angle? Well, the C in the CA stands for cosine. The A stands for adjacent, and the H stands for hypotenuse. So what this is saying is that cosine equals adjacent over hypotenuse. Now in this triangle right here with this angle, 3 is our adjacent side, and our hypotenuse is 5, which means that the cosine of 53 equals 3 over 5. Now last but not least, let's look at tangent. So if we have the tan of 53, well, we use TOA, opposite over adjacent. So the opposite side is 4, and the adjacent side is 3. So tan 53 is about 4 over 3. Now how can we use this to find unknown side lengths? So as we can see here, we have an unknown side length x. How can we find this using SOHCAHTOA? Well, we would first look at the angle that we are given, the 30 degrees, and we would see what other pieces of information we are given. So we are given 5 centimeters, and now we would look, is 5 centimeters opposite to 30, adjacent to 30, or is it the hypotenuse? Well, in this case, it is opposite to 30. And now we would look at the side length we're trying to find. So we're trying to find side length BC. Now is side length BC opposite to 30, adjacent to 30, or the hypotenuse? Well, in this case, side length BC is the hypotenuse. So now we know we're dealing with the opposite side length and the hypotenuse. And now we look at our SOHCAHTOA. Which of these three ratios, sine, cosine, or tangent, has the opposite side length and the hypotenuse? Well, the answer would be sine. It has opposite and hypotenuse. So we will be using sine to figure out x. So we simply start off by doing the sine of 30, the angle we're given. So as I mentioned, the sine of 30 is going to be the opposite divided by the hypotenuse. So the opposite side is 5 centimeters, and our hypotenuse is just simply x. So sine 30 equals 5 over x. Now we are trying to isolate x, so we can solve for it. So to isolate for x, we multiply both sides by x to cancel it out on one side, and then we divide both sides by sine 30. So now x equals 5 over sine 30. Now on your calculator, look for a button that says sine, and this button can be used to figure this equation out. So on your calculator, do sine 30, and then do 5 divided by sine 30. And this should give you the answer of 10 centimeters. So x is 10 centimeters. Now let's look at another example, triangle DEF. Now before you begin, it's usually good practice to write SOHCAHTOA on your page, just so you can refer to it. Now we're trying to find side length DF, which is x. Now we start off by seeing what we're given. So we're given side length DE, which is 7 centimeters. And this right here is adjacent to our angle, which is 50, angle DEF. Now what we're trying to find, side length DF, is opposite to our angle. Now we look at our SOHCAHTOA, which has both opposite and adjacent. Well, the answer would be tan. Tan has both opposite and adjacent. So we're going to be using tan for this triangle. Now we start off by doing the tan of 50. And we know the tan of 50 equals opposite, which is x, over adjacent, which is 7. So tan 50 equals x over 7. Now we multiply both sides by 7, and we have x. X equals tan 50 times 7. Now on your calculator, just do tan 50 and multiply it by 7. And this should give you approximately 8.34 centimeters. So one important thing to note is that SOHCAHTOA only works for right triangles, and this is a common mistake. People do this with non-90-degree triangles, but this only works with 90-degree triangles. So keep note of that when doing questions such as these. Here are a few examples that you could try, and I encourage you to pause the video and try them. The answers will be displayed in a few seconds. Here are the answers to the previous questions. Now, what if we want to find an angle instead of a side length? So right here, triangle XYZ, we're trying to find angle YXZ. So as you can see this little zero with a line through, this is called theta. And this is how we mark angles. So like before, we look at our reference angle, which is angle YXZ. And we look at what we're given. So we're given this side length right here, side length XY, the 10 centimeter one. And this right here is adjacent to angle YXZ. Now we look at this side length right here. This right here is the hypotenuse because it's opposite to the 90-degree angle. So we know that we're going to deal with an adjacent side and a hypotenuse. So what can we use? Well, cosine. Cosine has adjacent and hypotenuse. So like before, we do the cosine of theta. And as I mentioned before, theta is just a variable for the degree. And this equals adjacent, which is 10, over hypotenuse, which is 15. Now how do we get theta by itself? Because we want to figure out theta. Well, we would use cos inverse, which is cos with a little -1 on top. And this is the reverse of cosine. So if you think about division as the reverse of multiplication, well, cos inverse is the reverse of cosine. So if we're doing the reverse of cosine, we're canceling out cosine. And if we do inverse cosine on one side, we do inverse cosine on the other side. And this leaves us with theta equals inverse cosine of 10 over 15. Now on your calculator, cos inverse should be a secondary function. So if you click shift and cos, you might find cos inverse, or other ways your calculator uses to find cos inverse. So after you type in cos inverse in your calculator and 10 over 15, theta should equal approximately 48 degrees. Let's do another example, triangle XYZ. So right here, we are trying to find theta, and we are given this side length right here, which is adjacent to theta, and this side length right here, xy, which is opposite to theta. Now we look at which has adjacent and opposite. Well, the answer is tan, TOA. Tan has opposite and adjacent. So like before, we do tan theta, which equals opposite, 13, over adjacent, 17. Now to cancel tan on one side, we do inverse. So theta equals tan inverse of 13 over 17. After this, we simply put it in our calculators, and theta should equal approximately 37 degrees. And as you can see, it's really easy. You can figure out the angles and side lengths using SOHCAHTOA. But I will once again reinforce that this only works with 90-degree triangles. So only do this with 90-degree triangles. Now here are a few more practice examples on finding angles. I encourage you to pause the video and try them, because the answers will be displayed in a few seconds. Here are the answers to the previous questions. So if you have any questions, you can leave them in the comments below, and they will be answered as soon as possible.